All right, let's go through another example of drawing with loose dot structures with formal charges with now, like, let's say a polyatomic ion. So let's go through that real fast. So let's go through an example of this with a polyatomic ion of ClO2 minus. Once again, our first step is always to find out how many or total number of valence electrons. So in this case, we have one Cl and two oxygens. But now what we have to do is count for this -1 charge. And so if we have a -1 charge, that means we've gained one electron in total. So a -1 charge equals a +1 electron count. And so if it is a +1 charge, that would mean it's a -1 electron count. And so in this case, we have 1 times 7 valence electrons from chlorine, plus 2 times 6 valence electrons from oxygen, plus an additional 1 from the -1 charge, and that is equal to 20 total electrons that we have to draw. And then from this, step 2 is always to draw single bonds attached to the central atom. And so we have Cl is our central atom, so we have Cl. And then we have single bonds attached to each of our oxygens. And so then our step 3 is to make sure that we add 8 electrons to outer elements. And then if that completely fills up and we've done that all, and we still have extra additional electrons that we have not counted for, then we add dots or electrons to central atom. So in this case, this oxygen right here, or let's see this one right here, has one bond, which is 2 electrons, so it needs an additional 6 dots to get up to 8. Same thing over here, one bond, so it has 1, 2, 3, 4, 5, 6 dots in order for it to have 8 electrons. Then what we realize right now, we have a total of 2, 4, 6, 8, 10, 12, 14, 16 electrons, but we need an additional or a total of 20 electrons. And so we add those additional 4 electrons to our central atom. So 1, 2, 3, 4, so that now we have a total of 20 electrons drawn in this loose dot structure. Then step 4 is to find out the formal charges of all the elements. And then if that is also the case, then we also have to make sure that we might have to redraw this to have as many 0 charges as possible. And so in this case, what we have to do is find out the formal charge of our oxygen. So oxygen has a formal charge. Remember, formal charge is equal to your number of valence electrons. So oxygen has 6 valence electrons, minus how many non-bonded electrons we have, which is 1, 2, 3, 4, 5, 6. So 6 electrons, minus the number of bonds, which is 1. And so the oxygen has a -1 formal charge. So this one has a -1 charge. Same thing over here, since it's the exact same thing as this oxygen over here. Then we have to find the formal charge of Cl, our chlorine in the central atom. And so this has a formal charge of 7 valence electrons, minus it has 1, 2, 3, 4 dots, minus 2 bonds, and so it has a total of a +1 charge. And so once again, we realize that we want to get as many, or get rid of as many of these positive and negative charges as possible to get as many zeros. And so what we could do is redraw this so that we have a double bond. And so once again, let's just redraw this. So that's the exact same thing. To start us off, 1, 2, 3, 4, 5, 6. Single bond to oxygen, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4 dots. And so once again, what we could do is grab one of these lone pair of electrons and convert that into a double bond to change the charge of the -1 and this +1 to a more favorable value. And so this would be drawn as 0 or O single bond to Cl, but now we have a double bond between the Cl and the oxygen, and then these dots over here stay the same. All of these dots stay the exact same everywhere else. And so now what we have to do is figure out the charges that have now changed from our Cl and our oxygen over here. And so our oxygen has a formal charge now of 6 valence electrons, minus, it has 1, 2, 3, 4 dots, minus 2 bonds, and that is equal to a formal charge of 0. So this now has a formal charge of 0. Remember, this oxygen over here has not changed at all, because it's still the same as over here, so this still has a -1 charge. Then we look at the chlorine in the center, and this will have a formal charge of 7 valence electrons, minus, we still have 4 dots, but now we have 3 bonds, and so this has an overall charge of 0 as well, and so this chlorine has a 0 overall charge. And so now we have a lot of 0 charges and just one -1 charge, which we can never get rid of since our overall charge of ClO2 is a -1 charge. But now what we have to do is compare this to, let's say, what if we made another double bond? So what if we grabbed these electrons, let me redraw it over here. So this is going to be redrawn as this over here, oxygen, Cl, double bond to oxygen. Same dots are still the same. But what if we converted another double bond? So what if we converted these 2 electrons into another double bond over here? So what happens to our overall charges at this point? And so what this would transform into would be O, double bond Cl, double bond to O. This will have 1, 2, 3, 4, 1, 2, 3, 4, and then this will be 1, 2, 3, 4. Right? And so now we have to figure out the formal charges of all these things. Thankfully, we have already figured out the formal charge of this oxygen right here, which is the exact same thing as this one over here, right? Which is a 0 overall charge for both of those. And so all we have to do now is figure out the formal charge of our chlorine in the center, which is equal to 7 valence electrons, minus, we have 4 dots still, but now we have 4 bonds, and so this will have a -1 charge right now. And so now the question is, which one of these two is favored? The more favored one is that the higher electronegativity element will have or will want to be the negative charge. And so in this case, we have to compare oxygen to Cl. Which one is more electronegative? There's something called the Pauling scale, which I will give to you in class, and that is just a value of how electronegative they are. And so if we looked at those values, which on this chart is that oxygen is I believe 3.5 on the Pauling scale, and Cl is, I believe, a 3.0 value on that Pauling scale. And the higher the value, the higher the electronegativity it is. And so oxygen is higher electronegative or more electronegative. And so oxygen will be the one that wants the negative charge in this atom or this compound. And so in this case, if we look and compare these two drawings over here, oxygen wants to be the negative charge rather than the chlorine, and so the favored one would be this drawing right here. And so if we redraw it over here, we have oxygen, single bond with chlorine, double bond to the oxygen over here. Still the same thing over here. We saw the formal charge that this is a -1, this is a formal charge of 0, this is a formal charge of 0. And then since this is a polyatomic ion that has a overall negative, or in this case, or positive charge, in this case it's a -1 charge, what we do is we draw a bracket around the entire thing and then write the overall charge for the entire thing and outside of that bracket, just like we used to do for Lewis dot structures of ionic compounds.